Hey there, everybody. We're about to do a live demo here. If you'd like to join me at the Pilvi Theater, come on in. You can grab a nice, comfortable seat, and we're going to give you some great information. You can see kind of a cool demo being set up here by AWS. We're going to do a microgrid demo. All right, well, let me welcome to the stage without further ado from AWS. This is Bob Edmiston.
Hello, my name is Bob Edmiston. I am the user experience researcher for AWS IoT. And as part of my job, it's really important that I make sure that our products are completely usable for customers, not just based on the UI that they see in a usability lab, but make sure that the actual end-to-end user experience is for real usable. So to that end, it's important for me to do some proofs of concept just on my own to make sure that our user experience is as bulletproof as we could possibly make it. So one of the people that inspired me was this guy named Yehu Garcia. He's in LA, and he's a maker. And he was inspired by what happened in Puerto Rico after the hurricane came through. The utilities and the power was not available to the people for a very, very long time. So rather than despairing, he actually cobbled together some laptop batteries and inverters and small solar panels and made kits which he took to Puerto Rico and set up for people so they could have a light in their homes, recharge their cell phones. And that's kind of how this DIY microgrid movement happened. And since then, he's collaborated with some other people who could develop PC boards, and he developed this DIY PC board system that you see here on the right of the screen. They're basically PC boards that it's a freely available design that you could just have your own PC boards printed and then build your own rack. So what I did was I built a 1 kilowatt hour battery here because utilities sell electricity in 1 kilowatt hour increments. So as part of my learning, I built that, and I also used a solar charge controller so I could use energy from renewables. And I have an inverter here in the bottom, which produces 125 volt AC current. And then I have an ammeter, which can give me amperage measurements. And I have a voltage divider, which can give me voltage measurements of the pack. And in the upper right-hand corner here, or upper right-hand corner, this is an Arduino, which I use to do the analog to digital measurements. So this particular one is a Ruggedduino by Rugged Circuits. The nice thing about it is that it's very immune to damage. You could hit any of the pins with 30 volts and not hurt it. So that's rather useful. So the measurements are taken by the Arduino and sent over a USB cable to the Raspberry Pi every 3 seconds. And from there, it is sent to AWS IoT Core. And from AWS IoT Core, that information can be fed over to IoT Analytics to where we could do some smarter stuff from there. So again, the reason I did this was to make sure that I understand our customer experience and can replicate it and make sure that the entire thing is good. So for the past month, what I have been doing is running my workstation at work all day long on power that I bought the previous night at half price. So using off-peak pricing. And while that is one goal, which is kind of fun to do and to learn about, the system basically turns on at 10 p.m., recharges a bank, and then in the morning, I run it off the battery during the daytime. But in order to use cloud intelligence to run the system to drive the cost down even further, the way this is set up is the information is being stored in IoT Analytics every 3 seconds. So using machine learning, I will be able to have it learn how much energy I use every day, and also look at how much energy my solar panel can generate each day. And by using that information and also accessing weather feeds to see if it's going to be sunny tomorrow, I can minimize my spend on electricity from the grid, because it can predict how much I will need to use tomorrow. It'll predict how much I'll be able to get from solar tomorrow, and then purchase less, and purchase it at the lowest possible cost. And if in the future we can use the spot price of electricity as a data feed, it can use that information also to decide when to purchase energy. So if there's an excess of wind energy on the grid that's for sale at a lower price, it could take advantage of that. So, so in order to make all that happen and work in the cloud, it needs something which is pretty easy to use for doing all that complex event processing. So that's where IoT Events comes in. So IoT Events can take this telemetry data, and then on the cloud, it can define states. Like we have a state of charged, a state of discharged, charging, discharging, as well as knowing the voltage of the battery pack. I can then define transitions for when to go from one state to another, and have that based on events which are either coming from the IoT device itself or coming from other data feeds, like the spot price of electricity, weather data, information like that. So what's next is actually doing all that ML work and the AI and developing a system which can monitor and control the system, so I don't have to do any of that. So it can automatically improve itself over time to minimize my spend on electricity. So if you are somebody interested in renewables or work for a utility that has an interest in renewables or storage, please, I invite you to come collaborate with me on some of these ideas so we can make sure that IoT Events really is dialed in to empower these scenarios. So at this point, that's about it in terms of what I have to share here. Hopefully by next reInvent, I'll have some of the ML and AI stuff set up so where I could demo that. But that's definitely going to involve some collaboration. So do I have any questions from the audience here?
Anybody? I'll bring you the microphone so we can all hear.
So really awesome stuff. I can see lots of applications, especially in developing countries, right, where energy is not in great supply.
Right.
Does this take a lot of technical skill to build, or is there a way for people out there who could really benefit from this to be able to do this on their own?
Fortunately, so one of the advantages of having the PC board for building your lithium-ion battery packs is that it eliminates the need to learn how to spot weld lithium batteries. That's a very tricky, difficult to learn skill. So with these PC boards, you basically solder on battery holders that you can buy just off the shelf, and then you snap in batteries, and then you build the stack. Okay. So it makes it a lot easier. But you don't have to do it with a lithium battery. This equipment works equally well with standard car batteries, regular lead acid flooded batteries. You can also use it with LiPo or lithium polymer packs, which you can just buy off the shelf for hobby purposes.
And how long does it hold the charge?
So this stack here will hold a charge for probably about a month before it starts to drop off. But since I'm using it on a daily basis, I don't really have quite that much of an issue. So you're absolutely right. In villages throughout Africa and in island communities off of India, microgrids are really making a huge difference for people that have never had access to stable, reliable electricity. And they're able to use wind, solar, and even diesel generators to make up the difference to where these people can actually have electricity 24/7 in a way that isn't too expensive to maintain.
Right. Thank you.
Oh.
Have you thought about monitoring how when the batteries wear out, like how good they are, and when they might need to be replaced? Because if you were to use this setup for the long haul, that would be an important metric.
Oh, absolutely. So with the ability to measure voltage and amperage and accumulate those measurements over time, you could mine that data using ML to see, is the pattern of charging and discharging voltage relative to amp hours spent, is that changing over time? To where you could learn that your batteries have depleted to a certain point to where you need to replace them. And with a system like this where the batteries are just snapped into holders, it's really easy to resell the entire pack. You just pop out the old cells, slap in new ones after 3 years, and you're good as new again.
And how does this system relate to the stuff Tesla's been doing with their home battery system?
This actually is very similar to a deconstructed Tesla Powerwall. One of the challenges with that some local utility regulations have is whether you can take battery systems and connect them to solar and the grid. Usually you have to choose from one or the other. You can't have it connected to both.
Why is that?
Local rules.
Okay.
Right. So hopefully we can come up with systems that use cloud-based intelligence to do that kind of optimized drawing between renewables and the grid and help dissuade those fears and make for better rules around such things.
Anybody else? Any questions? Interesting stuff.
Okay. Well, thank you very much. I appreciate your being here.
Thank you so much. Thanks, everybody.